Hello, I'm audible. Hello, everyone. Welcome back. Today, I'm planning to give you a demo that how to make a basically 8-bit adder. Uh, Let me summarize all the previous things what we have done. Okay, so we are planning to make a one. We are planning to make a basically 8-bit adder. Okay, so let me share you the complete design which already we have prepared. Okay, uh, let me. Okay. So ultimately, you all have to make the circuit of or a block of calculator. Okay, like this is your sine calculator. Okay, in this sine calculator, you have push into symbol. Okay, in this sine calculator, you have adder, subtractor, multiplier, and divider, and then you have to summarize it. Okay, so I'm not going to give you the brief description because ultimately you have to design it, right? So what we have done till date, our plan is to design a 8-bit adder. So before that 8-bit adder, how basically we have approached to 8-bit adder. Let me share you. So we have designed first half adder. Okay, this is our half adder. This is the tool which we are using, and I have already shared the description. That is the tool links of Windows 10 for Windows 10 and Windows 11. Okay, so let me share you where I have shared each and everything. Okay, so if you go through this playlist, I have first shared you how to install the Xilinx ISE for Windows 11. So if I click here, in this description, I have shared the link to download the tool and then a complete video how to install the tool for Windows 11. See, okay, this is the link which already is mentioned there. Similarly, for Windows 10, maybe some of them having the Windows 10. So for Windows 10 also, I have already shared the complete information. Okay, so everything I have already shared. This is the downloadable link for Windows 10, the link I see, right? And then I have created a video on how to make a half adder, full adder, and then implementation of 8-bit adder. Okay, using the clear. So in this video implementation of 8-bit adder, we have not used the bus. Today, my planning is to use the bus. Okay, what is difference between the bus and without bus? That you can get a more clear picture after the designing. But let me show you. So this is a 8-bit adder circuit, and you can see here in this 8-bit adder circuit, you can see here there are so many lines are here. Okay, so many lines. These lines for A and B, for A0, B0, A1, B1, A2, B2, B2, A3, B3. There are so many lines are here. Okay, it's look very complex. Okay, so Xilinx has given the feature to avoid the multiple lines. Okay, to avoid the too many lines, we have an option to create this multiple lines in a bus. Okay, bus means vector. Okay, a bus means just like we see a normal bus. Okay, in a bus, more than 30, 40, 50 passengers are there. Okay, so with the same concept of the bus, of the transport road bus, the same concept used here also. So in a single line, you can inbuild one bit or you can save one data, two data, three, four, five, six, seven, eight, nine. So this is called a bus architecture, or you can say a bus method. Okay, so let's start designing the 8-bit adder using the bus. Okay, 8-bit adder using the bus method. Okay, so for this, again, this is something different. Okay, here we have not used the bus, but here I'm going to use the bus. Okay, so I'll click on again. Let me summarize. This is a design window. Okay, complete. This is a complete design window. In the design window is divided into two parts. One is hierarchy and one is process. Okay, so this hierarchy process, like we have to give a UCF, we have to implement it on a FPGA file. So for that we have to select the implementation. Okay, so if we select the implementation, you will see here there are a lot of options of process started here. Okay, and this is the simulation option. This option is only enabled only for the simulation. Okay, not for any other implementation process, right? So let's start. Right click, new source. Okay, select schematic, then select header, write the name. Okay, please write in proper way. Okay, your documentation should be look like very professional. Okay, don't write my name, my header. Okay, and then start using the underscore header bit 8. Okay, with clear. Okay, or you can write header 8 bit clear. Okay, and then select next. Or I can write one more thing here using the bus. Okay, just to differentiate between the previous one 8-bit adder and this 8-bit adder. Click next, finish. Okay, so this is your workspace. This workspace is basically look like a breadboard. Okay, the breadboard which we have used in our engineering. Okay, using this zoom in and zoom out, you can basically if you click on zoom in, okay, you will get the proper dot option. This dot option is basically help you to connect the components. Okay, like this. Okay, so what I will do here, I will call 1-bit full header. So I will call my previous 1-bit full header, which I have already prepared, created as a symbol. Okay, so this is not a right view, so I will use the control R and I will rotate the symbol like this. Okay, like this. 1, 2, 3, 4, 5. So 8-bit, 12-bit, 10-bit, whatever you want, you have to basically mention, or you have to add the numbers, right? If 8-bit means 8-bit adder. So 1, 2, 3, 4, 5, 5, 6, 6. So I have to add 2 more. Okay, okay, like this. Okay, so okay, like this. Okay, so you will call your 1-bit full adder 8 times. Okay, 8 times. Now I want AND gate, because this clear part is very important. Okay, so what I will do here, I will add AND gate. If you don't know why we are using AND gate, then please go to the previous video and to select N2. So basically, to make things faster, I have just copied and this is not correct. So what I'll do, I'll Control Z, Control C. Okay, you can do independent also. If you are not able to see the wire of AND gate output, then it's better to use the independent. Okay, so Control V, paste. Okay, see, you are not able to see the AND gate output. Okay, so in that case, go to the symbol and again call AND2. Okay, like this, like this. So why I'm using the AND2? I'm using the AND2 so that I can develop the clear logic. Okay, like this. Oh, like this. Okay, so we have one input, that is a A0, B0, sorry, A0, A1, A2. One input of every AND gate we will define as a A0, A1, A2, A3, A4, A5. Okay, that means up to A8. Sorry, A0, A1, A2 up to A7. And this is your B0. Okay, B0, B1, B2, B3, B4, and etc. Okay, so now I will take one wire. Okay, and I will take one wire, this wire, and I will like this. Okay, and I know that this is your A. Okay, I'm going to add one IO marker. Now I'm going to create a bus. Okay, so for to creating the bus, we have to make one. We have to basically design one wire, and as we know that A is my input, so I will connect A input. Okay, this one. A. Let me make it more zoom in. So I'm going to assign the name A, that is input A. So right click and A. Okay, now you have to basically define the input in terms of the MSB and LSB. Okay, so I'm writing from MSB to LSB, that is 7:0. Okay, so for 7:0 is A, write A small bracket 7:0. Now after writing this, what you will see here that the dimension of the wire is look like a thick wire. Okay, currently it's look like very thin wire. Okay, now I will click OK, apply OK. You can see here the wire is look very thick now. Okay, that means this wire is now 8-bit. It's carry the 8-bit. If you put a mouse here, you can see here net is of A7 and this is of input polarity. Okay, now we have to connect. Now we have to connect uh, the input of every AND gate, that is the A input of every AND gate with this line. Okay, so how you are going to do it? For that, we have to basically use the tab. Okay, so this is a tab. So if I'm putting like this, okay, okay, you can change the direction from here: top, right, left, bottom, like this. So basically what I'm going to do it here, I'm basically connecting, I'm using the tab. The tab is connected to the bus wire, and with this bus wire, I'm going to connect my input A. How? A0, that is my A0. Because 7:0. Okay, so this is my, the rightmost is my LSB and leftmost is my MSB. Okay, so like this. Okay, Control Z. Sorry, press K. So connect this like with this. Okay, like this, like this. Okay, so now again we'll go to again tab and we'll add a tab. Okay, tab for every A input. There is one more method, even you can like this, like this. Okay, so I will add one more for B. For B, oh sorry, one mistake I have done. Actually, we have to make a separate line for B. Sorry. So let's connect all A input with this tab. Okay, use the wire like this. Okay, this. Okay, so now we have to give a name. Okay, one is left. So how we can give a name? Okay, how we can assign the name? For assigning the name, we have to select this add net names. Okay, for this, as we know that I'm moving from 7 to 0. Okay, so I will write here a small bracket 7. Okay, so every time you have to just copy and paste, it's better to use this thing. Keep the name, increase the name, decrease the name, or clear the name. Okay, so if I'm going from down from 7 to 0, so I will select this, decrease the name. Okay, if I'm going from increase the name, that means from 0 to 7, and keep the name means only one time. Okay, so you will see what how it is going to work. So right, so select A7, write A7 starting, and click on this wire. Okay, see A7, automatically it will take A6. So basically we have to give the naming also. A6, A5, if A3, A2, A1, A0. Okay, like this. Oh, okay, right. So A part is completed. Okay, now let's start for B part. So again go to the wire. Okay, this time take wire from here. Okay, like this. Like this. Okay, and then name. This time write B, input B. B 7 is to 0. Okay, 7 is to 0. Okay, now you can see here the dimension, the thickness of the wire is increased. And now connect tab. Okay, so tab. Just a minute. Okay, now start connecting tab. First to zoom in. This 1, 2, 3, 4. This is 5. Okay, then 6. Very easy. See, I am guiding you how to design the hardware. Okay, so with the help of Xilinx ISE tool, which is now outdated, but still this tool is available to learn the digital. Okay, now we have to connect the wire. Go to wire and connect the B input. This is my B input. I'm taking this one input of every AND gate connecting to B. Okay, so let's connect this from here. This. You have to be very sensitive while connecting. Okay, you should not connect the output to any other input. You should very attentive in connecting the gates input or output. Okay, if you made any mistake, then very tough to identify. Okay, it may take 1 day, 2 day, 3 day, or only 1 hour or even 1 minute also is okay. Okay, so this is your B in, escape. Okay, like this, like this. Like this. Okay, see, I have connected the B input. Okay, now I will give the name. So go to the add name, like this one. Select decrease the name because I'm decreasing. Okay, I'm following the decreasing method, like 7 6 5 4 3. Okay, if you have given the left side like a 0 to 5, then select the name, increase the name, or keep the name is one time. Okay, then write it here B, capital B. Okay, again, one more thing very important. Uh, you should maintain the name of every input output. You should not write, or you should not use in terms of like a small letter somewhere and capital letter somewhere. Okay, if you are using the capital letter, please use the capital letter. If you are using the small letter, please keep the small letter. Okay, so this P7 Studio. Okay, so select the decrease the name, and automatically you will find here that you are able to P7, P6. One mistake. Sorry, I mistake. I have to write. Basically, I have to write B7. Only B7. Only B7. 7, 6, 5, 4, 3, 2, 1, and 0. Okay. So your A and B is completed. Right. Now we have to connect the uh, okay, we will connect reset later on. Now I have to connect the C out with C in, and the first C in I have to give the ground. So go to the symbol, select all symbol, select ground, G and D. Okay, then this is your ground symbol. So rotate like this. Okay, it's maybe it's overlapping. So in case of overlapping, you now again go to symbol, Digital is very wide, very wide. Okay, I can take complete 1 year with the same method. Okay, to guide you. It is very interesting and very challenging domain. If you don't know the digital, you can't understand a very long. What is this? Again, not able to mark it. Now, oh, okay, so मुझे थोड़ा वायर लेना पड़ेगा, बाहर निकालना पड़ेगा, like this. ऐसे करके, then again we have to select all symbol. Okay, symbol ground. So it will take time, okay, to learn this tool. Now connected. Okay, now this C out to C in. I already mentioned that this C out is connected to C in. Okay, because this carry out, basically this carry out is going to be the input of your bit. Okay, this C out, C in. Oh, made one mistake. Oh, sorry. This ground I have to connect here to the first one. Sorry, guys. This ground I have to connect here to the first. Oh, okay. So this C out is going to connect the C in. C out connect to C in. C out, C in, C out, C in. Now this C out to C in. Okay. If anyone is saying now, ki sir, full adder is 3-bit, then it is wrong. Full adder and half adder both are 2-input device. Okay. C in is basically a virtual automatic generating. Right. So now I have to connect this C in also, this clear button. Okay. Okay. This is clear. This is clear. Oh, not connected. It's clear. Okay, so now you have to basically connect the input of one AND gate to the clear. Okay, this is what I'm going to do it now. Okay, like this. So I will, in the last, I will tell you the difference of making the bus. Okay, that is how the bus will help you in solving your problem. That is how bus has solved your problem. Okay, like this. Okay, so now we have to give one clear input. Okay, so this is your clear underscore in. Okay, this is your clear in, right? But again, one part is left, that is sum part. Okay, so for the sum also we have to create a bus. For the sum also we have to create a bus like this. Okay, this time use the output port. Okay, so if you connect any input output port on left side, it will automatically take as a input. If you connect any input output port on the right side, it will take as a output. So if I have connected on the right side, you can see here it is already taken as a output. Okay, so rename it, and sum 7:0. Okay, see the bus change. Now add the tab. This time bottom. Select bottom like this. एक, दो, तीन, चार, 4, 5, 6, 7, 8. Okay, so now I have to connect all these bus like this, like this. Like this. Okay, so your bus sum is also connected, and the last is your cout. Cout. Okay, so okay, this is your final cout. Okay, now I will give the naming also, right? I forget to give a name of every sum. Right, so click on this. Okay, right here sum. Okay, please use the proper nomenclature. Don't use here in output port we have used the capital S, and here if you will use the small s. Okay, this will give an error. Okay, 7 and decreasing. So decreasing will be start from here. Sum. Oh, one mistake. If you're not able to connect your naming, then because of space. Okay, so you can give a proper space. Okay, see, I'm trying to connect it, but it was failed. It was not taking. Okay, like this. Okay, so now, okay, so let me remove the bus tab also. Oh. Like this. This is very interesting tool. I'm telling you. Here in North, whoever whoever has taken it has decided to start with the Xilinx ISE. Okay, everyone start with this tool only, and you can see here that you can design your logic, and you can share in your LinkedIn. Okay. So I can say now कि my students are much more faster than me. Okay, three more. Okay, it's like this. Oh, let's delete this. Okay, now I will again give a tab. Bottom one, four. You guys are always looking for the internship, right? So this is your exactly a internship. If you know how to use the tool, how to make the logic, you can develop any project and show, and you can show in your college, okay, as a internship project. Okay, what is internship? Basically internship is something like that ki you know something, okay, you know the HDL, you know the C, okay, and I'm the company, I'm working on HDL, I'm working on FPGA. So you have applied for the internship, so I will give you some project idea, so you have to implement it. If you implement it, then you can accept the certificate. If you don't implement it, don't accept the certificate. You can't expect the certificate. Okay, so everyone is making a looking for certificate or for a internship. So yes, this is true, but for that you should know the HDL, you should know the FPGA, you should know the embedded C. Okay, so your sum 7 is here now. Okay, delete this also. Let's start from scratch. Go to ABC, right here sum. Okay, like this sum. Decrease the number and start connecting. One. Oh, sub. Okay, if you're not able to write it here, right, then better to write it individually. Sum 6, keep the name. Sum 6, and now make it 5 and decrease the name. Oh, some problem. 5. Okay, keep the name. 5. Sum 4. Okay, I'm going one by one. Okay, showing this method also. Sum 3. Sum 3. Sum 4. Oh, sorry, sum 4. No, no, sum 2. Sum 2. Sum 2. Sum 1. And sum 0. Okay, like this. So everything is completed. You can see here. Now I will show you the difference between the two simulation. That is a simulation with 8-bit bus and simulation with normal 8-bit. Okay, that is a simulation. Difference between the design. Okay, two design. A first design which don't have the bus, and the second design which has a bus. Okay, so let me first verify that I have not done any mistake. So how I'm going to verify it? I will select this clear and I will see that all my clear button is connected. Okay, one mistake I have done, that clear button is connected to all gate, but the clear button of the adder is not connected to the clear pin. Okay, so you can see here only the clear pin is connected to all gates, but here the clear is not connected to the clear pin. That is, the clear pin of my full adder is not connected to the clear pin. Okay, so in that case what we will do, we will connect it. Okay, this is my clear. Okay, so like this is my clear. Now let's see once again. Now it is connected. Okay, so just connect one line and see that this clear pin is connected to, is basically going from the every AND gate. Okay, so basically this clear pin is controlling this AND gate also, and the clear pin is going inside the full adder also. Okay, but I think I have failed to connect the output. Oh, sorry guys. Okay, so okay, so basically I forget to connect the clear pin, that is the AND gate at the output side also. Okay, so let's do it. Okay, we should not leave it. Okay, sorry, I have to do it again. Okay, so basically I have to take one AND gate. Okay, it will take hardly 2 minutes for me. Control R. Control V. Okay, like this. Not connected. So now remove this. We will again add a tab. We will again add a bus and tab, and then this naming. Okay, we don't have to what I say. We don't have to allow any single mistake. Okay, take your time. It's better to invest our time here rather than investing your time in finding out the bug. Okay, like this. sorry. I have to add a bus here. Like this. Okay, and write it. Rename it. Capital SUM 7 is to 0. Okay, like this. Okay, and now add a tab. Where is a tab? Here is a tab. Two, three. Okay, we don't need for cout. Cout is separate. Cout is separate. Cout is separate. Okay, already exists cout underscore 1. It is exists because maybe some wire is already available with the previous name. That is why we can't give the same name. Okay, now connect this output to the bus tab. Like this. Okay, like this. Okay, now add the name from sum 7 decrease, select decrease S7 S7 S6 S5. You can see here the name S5, then S4 S4 S3 S2 S1 S0. Okay, okay, so design is completed. Okay, now let's go for the simulation. Now, okay, sorry, one part is left. Let's say clear part is left. Clear means this AND gate of sum is not connected to the clear pin. Okay, that is why we have added. Okay, so you have to connect any one. This. Okay, not possible. So we'll like bring here. Okay, not possible. So okay, now okay, now select clear pin. Now you can see here the red line. Now this red line is connected to all AND gate to all symbol of full adder. That means my clear is connected, and my this B is also connected, A is also connected, and sum is also connected. Now let's go for the simulation. Okay, before that, what you can do here, you can check the uh, design rules. Okay, select your design. Okay, select your design. So this is your design, your 8-bit. Okay, clear bit A adder. Okay, bit A adder. This is my second one. Okay, this one. Okay, so check design rules. If there is any issue, then any wire issue, then definitely it will give a error. See, there is no error. Why? Because I am following this very patiently. Okay, now I'll go for the simulation. As I mentioned, you have a two option, implementation and simulation. Implementation is used to implement the design on FPGA, and simulation is used to design for simulation. So select this, like this, run. Okay, now I will give you the basically the working of both. Okay, the previous adder without bus and adder with bus. Okay, let me open the simulation. Both, allow access. Okay, so see, I have opened the simulation file of the previous design, which has a independent or individually A and B. Okay, now I'm going to simulate, or I'm going to select the simulation of the design which we have it bus method, bus technology. Okay, right click, run. You can easily see the difference. Let me show you. Okay, now you can see here, see the difference. Now I don't require, see, your 8-bit is now converted into the, that is your 8 independent is converted into the one line. You can see B independent, all B76543 converted into the single line. All C out is because you have only one C out. Okay, and this is your, this all C sum is converted into the single line. Now the rest is your just a signal, so you can delete it. Okay, you can delete it. We don't need. Okay, we don't need. So we have only 8-bit A, 8-bit B clear in C out and sum. Now in second simulation, the first one, you can't delete A0 because you have to write, you have to give a value of from A to A7, then B0 to B7, and then independent clear, independent C out, and then you have to see the output. Okay, so if I delete all these line also, then also you have so many inputs which you have to force it independent one by one. Okay, one by one. Okay, one by one. There is no option, you have to force like this, force constant 0. Okay, force constant 0, 0, 1. Okay, like this. Okay, then again force constant 0, 0, 1, 0 means I want to give a 2. So from 7 to 0, 0, there is no option for you, right? Like this, 0. This is the first simulation which I am doing here without the bus. Okay, you don't have any option, but you have to force it independent. Okay, it is time taken task and complex also, 0. Okay, but here in case of a design with bus, but in case of design with bus, okay, in case of design with bus, you have to just write it force constant, okay, and 7 to 0 means 0 0 0 0 0 1 0, like this. See, within a second, within a second. Okay, similarly, now here you have to force the B also. So again, let's force 0 1 0 means 2. So 0, where 0 is a LSB and 7 is a MSB, 0 1, okay, 0. Because this simulation is very hefty task. Okay, you have to do so many times simulation, and if you are forcing every time the value, it is a time taking task and sometimes very frustrating. Okay, same thing you have to do many times. Okay, so it's better to convert into the bus and then force the value in a single time. Okay, b6 0, b7 0, like this. Okay, and then clear, you have a clear button, clear is 0, and you can't force the C out and sum. Okay, so let's see. So clear is enabled so that your all sum is 0. So I'll disable the clear and disable the clear 1 and C. So you are getting 4 0 0 0 0 1 0 0 0. Okay, the same thing now how it is look like here. I have forced 7 0 0 0 0 1 0. Same I will force 7. B also 0 0 0 0 0 1 0. That is 2. Okay, clear in, give clear in 0. Clear it 0. Okay, now see. Okay, maybe I have not forced radix default force constant. Okay, 8 times. Sorry, 0 0 0 0 0 1, no, no, 5 7 6 5 4 3 2 1 0. Okay, 7 times, 8 times. 7 6 5 4 3 2 1 0. Okay, and then B also apply C. Now here you can change the radix also. If I'm going to change the radix from the binary to unsigned decimal, see it is showing 2. Okay, this is the advantage of using the bus. Okay, now you can also convert this radix, some radix output of sum into the unsigned decimal 0, because clear is enabled. Now I will disable the clear. I will disable the clear and I will make it to 1, and let's see what is my output. Okay, I'm not getting my output. That means I have made some mistake. Okay, that means I have made some mistake because my output is not coming, right? Some mistake. So anyway, this is another a big task to identify the mistake where I have done the mistake. Okay, कुछ तो किया है मैंने, because I'm not getting the output. Okay, in the same way I should get the output also. So I have to debug it. So okay, so how to debug it? Basically, then in that case, now we have to recall all the previous one. Actually, one line is not connected. Okay, This one, line number 2, sum 2 is not connected. Sum 2 is not connected. Okay, sum 2 is not connected. Let's see how it is connected to C in sum 2. Okay, I got it. Uh, how many symbols we have for full adder clear? Okay, only one. Only one. Full adder underscore clear. This, I'm not getting the output at sum 2. Okay, how I have identified? You can see here. You can see here that this every line I am getting the output, but exactly this one, this sum number 2, 765432. This 2 is giving the red. That means this 2 is not connected. Sum 6, sum 5. Okay. Okay, no problem. I will identify and I will let you know where is the problem. I will again, I need to I need to debug it and I will share. So from here I'm closing it. Okay, but if you follow the same thing, right? If you follow the same way how I have designed, how this bit vector is basically solving a problem in simulation. If you are not using the bus technology, then you have to force the value one by one. If you are using the bus technology, you have to force the value in a cluster, that is in a club, that is you have to club all the value and you have to force. So this will basically save your time. Okay, so this is all from my side. I will find out the bug and I will show you the in next class. I will upload it. Okay, so if you are really serious about this course, you will definitely go through it and you will identify or you will implement in your design. Okay, so this is all from my side. Happy learning.